We're going to get into 11.3, so we're going to look at some independent and dependent events. These are called conditional probabilities, where one thing depends on the other. So this notation right here you're going to see today is the probability of A given B. So what that means is what's the probability of A happening if B has already happened. So let's look at an example. Okay, so we have 100 students here in this sample, and we're going to have some students in band and some students in student council. Okay, in students just in band from this 100 students, there are 45. Students in the 100 that are just in student council are 15. There are 5 that are in both, and there are 35 that are in neither. Okay. So all those should add up to 100. We want what is the probability that a student is in band, randomly chosen from this group of 100. So band, there are 50 total, 45 and 5 there. So we have 50 out of the total 100, which is simplified to 1/2. Okay? Now we want what's the probability that a student's in band given they're in student council. So what this part does is this changes our total. This is our new total. So instead of out of 100, we're just looking out of the kids in student council. So in student council, there are 20. So now this is going to be out of 20 students. What is the probability they're in band given they're in student council? So there are only 5 of the student council kids that are in band. So that is my probability that given they're in student council, that they're also in band. Okay. So the sample space just narrows, right? So it narrows from all 100 students to just the students in student council. Okay, so this, you guys, we could also use this. This is kind of a formula. This only works if there's an intersection between A and B. So I'm going to add that. Only if there is an intersection between A and B. Okay, so I'm just going to show you that this one still works. So A intersect B, so of the 100 students, there are 5 in that intersection. So if I use this formula, I'm going to have 5 over 100 over the probability of B. So B is student council, right? If I read it this way, this is my A, this is my B. So if I'm trying to find this using this formula, then the probability that they're in band, we found that to be 50 over 100. So, oh, I'm sorry. I talked about band. Student council. The probability they're in student council, I have 20 out of the 100 students in student council. So if I divide these fractions, I have 5 over 100 times 100 over 20. Right? Those cancel, so I get 5 over 20, which is 1/4. So I still get 1/4. This is just another way to kind of think about it. So this formula is something you can use, and that works if there's an intersection. It's also not too terrible to think about when you have a Venn diagram. Just knowing that we have a new total is really important. Okay, we're going to make a two-way table for this one. So we have a youth basketball club has 60 members. 10 are left-handed, 22 are right-handed, and under 6 feet tall. 3 are left-handed and are 6 feet tall and over. So kind of the categories we have are height and then their dominant hand. So we're going to create a two-way table. So I need 4. Let's see, we got 1. Okay, so over here we have totals. Let's do smaller than 6 feet, so less than 6 feet. This one is greater than or equal to 6 feet. And then we have left-handed and right-handed. Okay, so total we had 60 members total, okay? 10 of them are left-handed, so total out of the 60, 10 are lefties. 22 are right-handed and under 6 feet, so right and under 6 feet, 22. 3 are left and 6 feet tall and over. Okay, so now we should be able to fill in the rest of the table. So this row has to add up to 10, so this must be 7. Add down this way, we get 29. Subtract here, I get 31. This has to add up to be 31, so this must be 28. And then 22 plus 28 is 50, and those should add to 60. Okay? So now that I have this two-way table, let's find some probabilities. So what is the probability that if we randomly select one of these players, that they're left-handed? So this is going to be, I have 10 total lefties out of the total 60 club members. So this is 10 out of 60, or 1/6. Okay, what is the probability that they're left-handed given they're less than 6 feet tall? So again, this is my new total. So less than 6 feet tall is my new total. And the probability that they're left-handed out of this. So have to be under 6 feet tall and left. So 7 out of those here. Okay, again, I could have done this formula. Okay, so I'm just going to show you that again too, just so you can see we'll get the same thing. So the probability of left and under 6 feet, sorry, now this is a little funky notation. That intersection, left and under 6 feet, is 7 out of the 60, right? The probability that they are less than 6 feet is 29 out of the 60. So under 6 feet is 29 out of the 60. So this is where I divide these two, so that I am going to still get 7 over 29. So divide. Okay, so either way we're going to get the same thing. So to me the formula seems a little bit excessive. Honestly, I think it's easier just to think about your new total, but that's there for you guys if you find it helpful. Okay, that's it for lesson 3, day 1.